If one were to stand today in the sun-scorched plains of southern Iraq, one would see a world of shimmering heat and dust. The earth here is parched, cracked by a relentless sun. It seems an unforgiving place, a landscape that has surrendered to the desert. Yet, beneath this arid facade lies the ghost of a garden, a world teeming with life, a civilization that rose from this very dust, powered by an astonishing mastery of a single precious element, water. This is the story of a lost world, built not of stone monoliths but of something far more ephemeral and powerful. How the very first cities on Earth were born from the masterful redirection of rivers, a feat of engineering that still baffles us today. The mystery begins with a simple, profound question. How did a people equipped with little more than reed's clay and their own ingenuity transform this hostile wasteland into the cradle of civilization? The answer lies buried in the soil, etched into the very geography of the land, Mesopotamia, the land between the rivers, Tigris, Euphrates. These waterways were a gift and a curse, bringing life-giving water and unpredictable, ruinous floods. To survive and thrive, Mesopotamians had to control them. They became masters of water, bending its will. Not simple, a monumental undertaking that laid foundations for the modern world. More than digging ditches, a grand symphony of cooperation and ecological understanding. They observed the land, subtle shifts in elevation, the seasonal moods of the rivers, the very nature of the soil. From that, they built a system of breathtaking complexity and scale. An irrigation network that became the lifeblood of society. A technological marvel that fueled cities like Uruk-Ur. Their achievement is hard to grasp. They sculpted the landscape to their needs, creating a man-made Eden where once was desert, proof of deep, intimate environmental knowledge. Here lies the enigma. How did they achieve such precision? How did they calculate gentle slopes to carry water for miles without lasers or modern surveying equipment? Our story begins long ago, at the dawn of the Neolithic period, somewhere between 8,000 and 6,000 BCE. Humanity was at a turning point. For millennia, we had been wanderers, hunters-gatherers. But here, in a wide arc of land sweeping from the Persian Gulf to the Mediterranean, something extraordinary began to happen. This region, the Fertile Crescent, became the stage for one of the greatest revolutions. Small bands of people began to settle down, cultivate the land, domesticate plants, domesticate animals. They were taking their first tentative steps towards a new way of life, a life rooted in one place. The environment itself was the catalyst, surrounded by vast deserts, rugged mountains. Yet the Fertile Crescent was blessed by great rivers, Tigris, Euphrates. They created a long, narrow corridor of possibility. Each spring, as the snows in the northern mountains melted, these rivers would swell and overflow their banks, depositing a rich layer of silt across the floodplain. This created soil of incredible fertility, a natural gift that promised bountiful harvests. But this gift came with a challenge. Rainfall was scarce and unpredictable, and the floods, while nourishing, were often violent and destructive. The early settlers faced a paradox, a land of immense potential that was also fraught with peril. It was in grappling with this paradox that the seeds of civilization were sown. Early farmers quickly realized that relying on the whims of the rivers was not enough. To unlock the true potential of the land, they needed to manage its water. They began with small, simple innovations. Build a low earthen bank to protect a small plot of barley from a minor flood. Dig a shallow channel to guide runoff from a rainstorm towards their crops. These were humble beginnings, the first dialogues between humanity and the hydrological cycle. Each small success, each lesson learned from a failure, added to a growing body of collective knowledge that was passed down through generations. This slow, incremental process gradually transformed not only the landscape, but the people themselves. As they learned to control the water, their harvests became more reliable and more abundant. This newfound security allowed populations to grow. Small villages began to expand, becoming larger, more permanent settlements. The act of collectively managing water resources required cooperation, planning, and social organization on a scale never before seen. The true leap forward, the innovation that would define Mesopotamia, was the development of large-scale canal systems. This was not merely about guiding water, it was about fundamentally re-engineering the landscape. The Mesopotamians conceived of a plan breathtaking in its ambition, to create a network of artificial rivers, a circulatory system that would carry water from the mighty Tigris and Euphrates deep into the arid plains. These were not just ditches, they were carefully planned waterways, some stretching for many miles, designed to function as a cohesive, integrated system. This was humanity's first great infrastructure project, a testament to a new way of thinking about the world, not as something to be endured, but as something to be shaped. The principle behind this grand design was one of elegant simplicity: gravity. The Mesopotamians observed that the floodplain was not perfectly flat. It sloped, almost imperceptibly, away from the natural banks of the rivers. The rivers themselves, over millennia of flooding, had built up natural levees or ridges of sediment along their edges, making the land beside the river higher than the plains further away. They realized that if they could cut a channel through this natural levee at a high point upstream, they could use the gentle natural gradient of the land to draw water far from its source. The water would flow obediently, powered by nothing more than the pull of the earth. This concept gave rise to a complex hierarchical network. Large feeder canals, these main arteries, would then feed a web of progressively smaller distribution channels like the branches and twigs of a tree, delivering precise amounts of water to individual fields. It was a modular and scalable system, one that could be expanded over time as the population grew and more land was needed for cultivation. The coordination required to excavate and maintain such a network was immense. It demanded a centralized authority, a shared vision, and the labor of thousands of people working in concert towards a common goal. The result of this enormous effort was a miraculous transformation. Vast tracts of formerly barren desert, far from the riverbanks, were brought to life. The pale, dusty earth became a patchwork of vibrant green fields. The sight must have been astonishing. Where there was once only the shimmer of heat, there were now fields of swaying barley, groves of date palms, and lush vegetable gardens. This engineered oasis, wrested from the desert through sheer willpower and ingenuity, became the engine of Mesopotamian civilization. Perhaps the most profound mystery surrounding these ancient waterworks is the question of their design and layout. How did the Mesopotamians achieve the astonishing precision required to make the whole system work? You know, a canal has to have a slope that's just right. Too steep, water erodes banks and can breach. Too gentle, water stagnates and fails to reach distant fields. The ideal gradient is a few centimeters per kilometer. To survey and plot these gradients over vast distances, without modern transits, without levels, without GPS technology, seems almost impossible. And it's here we enter speculation, guided by tantalizing clues. Some scholars think they used a simple tool: water. A surveyor might have used interconnected vessels, or a long, shallow trough filled with water. By repeating this process and sighting along the water to a marked rod, they could plot a consistent elevation drop across the landscape. It would have been slow and laborious, demanding immense patience and meticulous attention to detail, but theoretically possible. This hands-on approach shows a society attuned to physical properties. Another part of the puzzle, their system of measurement. Cuneiform tablets show sophisticated mathematics, geometry, and a base 60 numbering system. Tablets contain calculations for field areas, grain yields, labor requirements. Likely they also held formulas and tables to plan canals. We have clay tablets that look like maps of fields and waterways. They had a system to record and transmit complex spatial information, a clay GIS. Still, a complete explanation remains elusive. The scale and integration implies centralized planning. How did they coordinate canals across dozens of communities? How did they model flow to ensure fair distribution? It hints at a lost body of engineering knowledge handed down by master builders and surveyors. This was applied hydrology born from centuries of trial and observation. The full extent of their methods remains one of archaeology's great unsolved questions. The impact of this mastery over water was nothing short of revolutionary. It completely redefined the carrying capacity of the land. With a reliable year-round water supply, Mesopotamians could achieve agricultural yields previously unimaginable. Fertile silt from irrigation constantly renewed the soil, allowing continuous cultivation without leaving fields fallow. All of it grew from the mud of irrigated fields, a civilization built on carefully managed water. The story of this ancient achievement is not just theory, it is written into the land itself and preserved in the artifacts left behind. For archaeologists, the landscape of southern Iraq is a vast open-air museum. Using satellite imagery and aerial photography, researchers can still trace the faint ghostly lines of the ancient canal systems. These features, known as fossil canals, appear as subtle changes in the color of the soil, subtle changes in the texture of the soil, or as low, linear ridges in the terrain. They crisscross the desert for miles, a ghostly map of the agricultural powerhouse that once flourished here. By mapping these ancient watercourses, we can begin to reconstruct the sheer scale and complexity of the network that sustained millions of people. On the ground, excavations unearth more tangible evidence. Archaeologists have discovered the physical remains of the canals themselves, their cross-sections revealing layers of accumulated silt, telling a story of use, dredging, and eventual abandonment. They have found the remnants of weirs and the baked brick foundations of sluice gates, their positions revealing the logic of the water control system. One of the most evocative discoveries is the canal marker. These were inscribed clay cones or cylinders buried at key points during a canal's construction, often by a king or governor. The most detailed information, however, comes from the vast archives of cuneiform tablets. The Mesopotamians were meticulous record keepers. Scribes recorded everything on damp clay, from royal decrees to simple receipts. Among these hundreds of thousands of tablets, we find a wealth of information about water management. There are legal codes like the famous Code of Hammurabi that contains specific laws regarding irrigation. These laws detail the responsibilities of farmers to maintain their section of a canal and prescribe harsh penalties for negligence that leads to flooding or water theft. They reveal a society where water rights were a central legal and social concern. Other tablets are administrative records detailing the allocation of water, the labor required for canal maintenance, and the yields from irrigated fields. Some even appear to be textbooks or manuals for scribes, containing mathematical problems related to calculating the volume of earth needed to dig a canal of a certain length and depth. These documents provide an intimate glimpse into the day-to-day running of the system. They show us a bureaucracy dedicated to managing this critical resource. A government whose primary functions included hydraulic engineering and resource distribution. The echoes in the clay tell a story not just of technology, but of a society organized around the challenge of mastering water. As we face our own challenges of water scarcity and environmental management, we would do well to look back at these first hydraulic engineers. They were the true pioneers of civilization who, with mud, reeds, and an inexplicable genius, made the desert bloom and left behind a legacy of questions that still echo from the dust.